Okay, so in today's lesson we're going to go through the internal tangent plane between two spheres. So first we look at a PowerPoint to give us a structure to the lesson and allow a discussion between the students. So first of all we'll go into our PowerPoint. So this is the idea for the class, the internal tangent between two spheres. So basically this orange profile is our internal tangent plane. So we've got our two problems there. So if we move on. Now, so allow the students to discuss from the last lesson what we would have dealt with. So when given two spheres, how do we construct the cones around them? So the idea of the last lesson will be that we would have dealt with the external tangent plane between two spheres. So this is what we would have did in the last class. So first of all, allow a discussion, so it's a class discussion for 10 minutes between the students to trash out what they learned in the last lesson. So there's a few pointers up here. So two spheres, how do we construct two cones around them? Once we have the horizontal trace and the vertical trace, what do we do? Once we have the horizontal trace, what do we do to find the vertical trace? So that's your oblique point projection method. Having found the normal to the tangent plane for each sphere, how do we use this to find the points of contact? So allow 10 minutes, pause the video now, and class discussion on what we would have learned in the last lesson. So where do we go from here? So we're going to further look at this. So if we have the external tangent plane, we're going to look at the internal tangent plane. And for just 2 minutes, maybe in pairs or in threes, whatever suits best to the class at the time, discuss what learnings from the last lesson will help us with this lesson. So the learning intentions can be written up on the board for the pupils to see and tick off as we go along. So there are the learning intentions there. Just allow a minute for the students to note these and maybe write them up on the board. So in today's lesson, the structure of it is we're going to go through a layered solution to the problem on SolidWorks. So we've our two spheres in plan and elevation, and we're going to find our internal tangent plane. Then, as a visual aid, we will look at a 3D model on SolidWorks, already made up of two spheres with two cones around them and our internal tangent plane. This model is very handy for the visual learners, as we have our horizontal plane, our vertical plane, our horizontal trace and our vertical trace, along with the ability to hide and show our internal tangent plane. So that's the structure of the lesson. Now we move on to the drafted solution of the layered problem on SolidWorks.
Okay, we'll start by drawing two spheres, one 55 in diameter, the other smallest sphere is 38 in diameter. So they're drawn in elevation and plan, and that's represented there. So the next step after that, so next step is we draw two cones, an upside down cone over the 55 diameter and an upright cone over the 38 diameter sphere. These cones are drawn at 60 degrees. So it's this angle here between the XY line and the pink line is 60 degrees to the ground line. So I'll give time now, so I can pause the podcast and we can the students can get this drawn. So the next step after this is, so the points are just brought down there to the plan. Your two spheres are drawn in the plan. So next, so where this cone crosses the XY line, this point is dropped down to the plan view. So the center line of the sphere in the plan. And the same here with the upright sphere. So we dropped in 2 points down here to the plan view of the center line, and we just marked them 2 points at the moment. So the next step after that, then we get our compass, we set it out to the distance where we drop down the points, and we draw our circle. So that's represented as the pink here, and the same. So it's wider here where the upright cone is, and that's drawn round. So the next step is we've to find our vertical trace. So I'll skip back. I'll go back here now 1 second. So what we have to do next is we have to find our horizontal trace in our plan. So what we know is we've a point, so the oblique point projection method is going to be used for this. But at first we're going to draw our horizontal trace in our plan. So what we do is we draw a line parallel tangent to both of these new pink circles that's roughly in contact in one point. We project that up to the XY line. So the next point, so this is called the green line here, is the oblique point projection method. So we draw a line parallel to this horizontal trace here. We draw that parallel with our sliding set squares, and that's brought up to here, the XY line. This then is next step is we bring a vertical line upright, so we don't know how far yet, and we bring from the apex of the cone, we bring a horizontal line across. So where the two of them cross, we mark that with a dot. For the vertical trace then, so we join where the horizontal trace meets the XY all the way up to where these two lines intersect, and that is our VTH. So you can pause the podcast there now, and students can catch up with this. So the next step is we have to find the points of contact in where the trace meets the spheres. So what we do is we draw, here's our normal to the cone. So we draw our normal at 90 degrees to the cone, and that's represented there in our elevation. And then, so where this line crosses the cone here, that's brought down to our center line in our plan, and we rotate around this circle. So also what we've done here is we've drawn our normal to our horizontal trace. So that's just drawn at 90 degrees, which can be done with your sliding set squares. So we've our normal in our plan view, and we've our normal here in the elevation. So the two of them are just drawn with your sliding set squares, set them up parallel with this line, and then 90 degrees into this. So what this gives us, where this is brought down, and where that circle arc crosses this line, that is our point. So I'm going to show this now in the next step. So 2 points marked in our elevation view and on our plan. So we can label it in. So it's point P we've labeled here in our plan and in our elevation. So that's basically where the trace crosses the two spheres in plan and elevation, and it's important that we have this marked.
So this is a model I made up on SolidWorks of this question of an internal tangent plane. Here we can see our bigger sphere was an inverted cone, and the smaller sphere was a cone at 60 degrees from the horizontal plane. We can see our tangent plane here, and we can see our horizontal trace and our vertical trace. So the reason why you do this is for the visual learners in the classroom. You can give them this model, or they can come up and you can show it on the laptop. If they have their own laptops, or they have their own tablets in the school, obviously they can use it. If not, it's a good visual aid on the projector. So what you could do is you could hide this first, the tangent plane, and you could ask the student as a quick assessment of the question to see what are we missing. So you can see here the question, we have only the traces, but it doesn't answer the question. So you just might ask them what's missing out of this 3D, and students would probably say that your tangent plane is missing there, and then you can go in and you can show the component, and this gives a understanding of where the plane comes from, and you can show that it's touching here and it's touching the sphere here. So another good thing about SolidWorks is you can actually show them, you can show the kids the different views, so your elevation, and then you can show them your plan, and this is what they see down on their question. So therefore you're directly relating what they have done in the class to the 3D model. I know I as a learner learn a lot easier when I can actually visualize and see something, and therefore other students might be the same.
Using a 3D model, we can allow students to show at the top of the class a visual representation of this problem. So we've already made out on the 3D printer our small sphere and our bigger sphere. So first of all, on our solution, we will have our vertical trace and our horizontal trace. This here, horizontal trace, is where we'll position our internal tangent plane. So if we get our plane, we'll do something simple here now, place it in between, just as a visual representation for the students, along our vertical trace, then our horizontal trace. This is a great aid for students to show them exactly the solution to this problem.